And what if we shift this? Amplitude is still the number in front of the x. Period is still 2 pi divided by the number in front of x, which is 1. That's 2 pi. I'm sorry. Amplitude is the number in front of the function, not the x. 3, there's none. But 4, we have a vertical shift at y equal to. So this is normally how we proceed. We start with the shifts first. Again, I could have used algebra. I taught this before using algebra. I found this to be much easier than using algebra to figure this out. So if I am to go to my shifts first, always, I go up to 2. Let's say this is 1, this is 2. Let me just center this really quick. So pretty much this is my new origin. And now from this point that I just mentioned, I move my amplitude. I move 1 unit above and 1 unit below. And I do the labeling ahead of time. This way I am done with that. If I start at 2 and I go up 1 unit, that would be 3. If I start at 2 and go down 1 unit, that is 1. A graph of a sine wave, if it's traditional, starts at the origin, but this is my new origin. Run up to the amplitude, back down to the starting point, and I'm done. And that's one full cycle, as smooth as you can. And since I have to label these points where the graph crosses the new axis and the amplitudes, and I know it's going to be 1/4 of the period, which is pi over 2 in this case. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That's one full cycle. I could sketch another period to the right or to the left. Let's go to the left on this one. And that would be another cycle. That is at negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, and negative 4 pi over 2. Now, I'm going to go to the next example, but I'm going to make it there, a bit more interesting. Now, you notice on this problem, the 3 is out of sync. And they do that. They do that a lot, especially with the phase shift, in physics specifically. They take the number, like the 5, and they could write this as 3, the cosine of 5x. And again, for the shift, when we do shifts, I'll point out what this means, but that's allowed. You could do that. That's kind of like looking at it this way. So in this case, 1, my amplitude, remember, it's the absolute value of negative 2, which is 2. 2, the period is 2 pi divided, this still qualifies as the number in front of x. 3, I don't have a phase shift. But 4, I do have a vertical shift because I have a number loose by itself. And 5, I notice it's a negative sign. So this is gonna reflect the graph. And that's all there is. That's pretty much everything. If I go to my shifts first, y equal 1. If I run to my shifts first, y equal 1. Oops, let me use a different color. Let's go blue. So if I run with to y equal 1, that's what I do first. Then I run my amplitude. 2 units above, that's y equal 3. And if I start at 1 and move 2 units down, that's y equal negative 1. Alright, and I do know how the graph look like. If I run a graph of a sine, it starts at the origin, the new origin. Now normally it would run up, but since it's reflected, it's gonna run down, back to the starting point, back to the amplitude, back to the starting point. So that's how they reflect. They only reflect with respect to the x-axis. That's one cycle. If I want to sketch another cycle, well, let's go to the right again. I could do it again. I could do as many of those cycles as is required. Normally, I'm going to ask you for 2 of those. It could be both to the right, or 1 to the right, 1 to the left. All what I need for all the labeling is pretty much figuring out what this point is. These are the points I must label on every graph. So, if I was to take 1/4 of the period, that will be pi over 6. Once I know that this is pi over 6, this is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and 8 pi over 6. I got everything labeled, and I'm done with the graph. How about the next problem? If I want to look at one amplitude is 2. We have a period of 2 pi divided by 2 pi, which is 1. Much better. Okay, and we want, oh, those didn't shift for a reason. There we go. And let me push this down a bit. Okay, 3. We don't have a vertical shift. That's the last thing we deal with. That's the toughest. We have a vertical shift of y equal -2. And 5, this is negative, so we reflect the graph. And that's all explained right here. That's what we mean by regular graph and reflect. And you always reflect with respect to the x-axis. So in this problem, and since I shifted that, now that's out of sync. Right there. If I want to graph this, I start with my shifts first. Y equal -2. Let's say this is y equal -1, -2. Again, you could really scale that any way you want. And I go to my amplitude. I'm going to move 2 units above this and 2 units below this. You know what? Let me not shrink the scale, because the labeling becomes a bit messier. So let's say this is -1, -2. And I'm going to move 2 units above and 2 units below. If I am at -2 and I run 2 units down, that's y equal -4. So the graph would start, it's a sine, at the new origin, so to speak. That's your new axis. And since it's reflected, it's going to run down, back up, and back down. And that's how the graph looks like. I'm going to go 1 period to the right and 1 to the left. Again, I'll alternate on those, and I do 1 cosine and 1 sine. So the main part for me to figure out is, once I know this point, because that distance equal to this distance, equal to this, equal to this, I'm pretty much set, and that's always 1/4 of the period. The period is 1. That's 1/4. This is 1/4. This is 2/4, 3/4, 4/4. If I wanted to go on, 5/4, and so on. To the left, you added 1/4 to the right. To the left, negative 1/4, negative 2/4, negative 3/4, and negative 4/4. And there it is. Next problem up. There it is. I have y equal negative 2 the cosine. Actually, this one I don't need much space. No, this is fine. 1. The amplitude is 2. 2. The period is 2 pi divided by 1/3. That is 6 pi. You multiply by the reciprocal. 3, 4, there's none. But 5, since there's a negative in front of it, we reflect. So the grid looks like a traditional. We didn't shift up or down, so starting from the origin, I moved up 2 units. And I labeled that clearly. And I moved 2 units down, and I labeled that clearly. Now, a graph of a cosine starts on the amplitude, but if it's reflected, instead of starting at the top and running down, I'm going to start at the bottom and run up. The points are the same, they don't change. Just the graph will flip-flop, nothing more. So the graph would look like this. And I'm going to go another cycle to the right. And in this case, the labeling would be if I take 1/4 of the period divided by, that's 3 pi over 2. So this is 3 pi over 2. Another 3 pi over 2 is 6 pi over 2. 9 pi over 2. 12 pi over 2. 15 pi over 2. 18 pi over 2. 21 pi over 2. And 24 pi over 2. And you could always check when you're done, if you really like, at least in this section, you could check that this took a complete of 6 pi, and wouldn't the other period be another 6 pi, and that's 12? You could always do that. That's not a problem. Now, let's look at the next problem. It has everything. It looks challenging, but looks could be deceiving. 1. The amplitude is 3/2. 2. The period is 2 pi divided by 3/2. So if I multiply by the reciprocal, the period is 4 pi over 3. 3. None. 4. We have a vertical shift of y equal 1/2, and it's right there. And 5, I noticed that that's negative, so you reflect. Okay, it has almost everything. The phase shift we're going to do on our next session. So I need to get this out of the way first. I start with my shifts. I have a shift of 1/2. Let's say this is 1/2. Right? Y equal 1/2. Then after I label that clearly, I go up 1.5. if I am at 0.5 and I go 1.5 up, now I'm at 2. And if I am at 0.5 and I move 1.5 down, I am at y equal -1. I would label this clearly because this is a must. Sketch the graph. If I proceed with the graph, a graph of a sine wave starts at the origin. This is my new origin. Instead of running up, it's reflected. So it's going to run down. And that is one full cycle. And if I sketch another period, let's say to the left this time because we don't want it to the right. And I'll label an extra point for you just to see how this works. Well, let's see how this works. If I run in and I start labeling those, whether you put them on the original x-axis or the new axis makes no difference. So I'm going to take 1/4 of the period. The period is 4 pi over 3. Isn't that pi over 3? That means this is 1 pi over 3. 2 pi over 3. Three pi over 3. 4 pi over 3. That's one period. To the left, negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, and negative 4 pi over 3. So this is one full cycle. This is one full cycle. And I'm just labeling that extra point because I just want to make sure that you know how to do that. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Wouldn't this be 5 pi over 3, 6 pi over 3, 7 pi over, and the list goes on? Now, something to get out of the way. These are graphs that come up. The last one I'm going to do before I conclude this video, and the next ones with the phase shift will come up on the next lecture. If I see an absolute value, this is how I think of an absolute value. I ignore the absolute value. I look at y equal the cosine of x. I know how that graph runs. That graph runs between y equal 1, I'm going to assume this is 1, and y equal -1. Shift this. Right there. Perfect. So what I do, I sketch the graph. I sketch the graph without the absolute value. Now, I'm going to make it dotted because this is kind of like my guinea pig. Start right there. And I do the labeling. And I'm doing this dotted because, again, this is not the graph of the absolute value. I'm just going to use that to figure out what the graph looks like. And the labeling is a must. That's not going to go away. This is 2 pi. This is 1/4 of 2 pi, which is pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So, when I slap an absolute value on this, all what this says, if I tell you y equal an absolute value, I'm telling you that y is always positive. So wherever y is positive, wherever y is above the x-axis, that's fine. Any negative part you reflect above. The positive we leave alone. Since this is negative, you reflect it above. You already did the labeling, and that's how the graph goes. So that concludes this part of the section. I will pick this up in the next video and talk about phase shift. For now, that would be it.